All right, so this is to kind of just check to make sure that you're ready for the homework. This is just a real quick review of the worksheet. So my hope is that you read through it, and I'm just going to give you the answers and a brief explanation. So make sure you've done this worksheet first, then jump over to this video, watch, check for the right answers, and then you'll be ready to go for the homework. So here we go. And this first one and the second one, they're actually very similar. But what I notice here is the word all. So by having the word all goes with population. And just as a reminder, that's sigma. So for B, you're going to throw all this into your calculator and you have sigma, and I think there's a little X on your calculator, but it's fine. Sigma equals 6.8, and it has the same units as the problem right here, thousands of dollars. So there's two ways you can answer this. You could say $6.8 thousand, or to round it to one decimal place, look at all the decimals in your calculator, and you could say 6,831.3. That's just another way to write it, because I already multiplied it by 1,000. So I took sigma from my calculator, multiplied it by 1,000, and rounded it to one decimal place. Sometimes you just kind of have to see how the computer is prompting you, because if there's just a box and then it says $1,000 after that box, well then 6.8 is the answer they're looking for. Okay, part 2. Here we have the average high temperatures in January for all of these years right here. And they gave us 4. That's a sample. If you didn't know that was a sample, look at this word right here. It tells us it's a sample. But what I'm saying is from 86 to 98, we have 86, 87, 88, 89, 90, plus 8, what is that, like 13 years? And it only gave us 4. So that's definitely not all 13. So this is definitely going to be sample, because it says it's a sample and it gave us a sample. And therefore, sample is S. Throw this in to your calculator. Oh, I could read the problem. It says find the variance. Well, we still need to know what S is from our calculator. So I know S is 6.73. And then variance is going to be S squared. So variance is going to be 45.3, because it says to one decimal place. And these are degrees. And variance is always squared. So we'd say degrees squared. Yay, fun. I know I'm going fast, but remember, this is supposed to be reviewing your answers, not showing you something for the first time. Okay, so here we have a situation where, and again, you've already read this, so I am just going to walk you through it. But we have the mean. So I'm going to write this on the side. So I'm just going to use the mean is 6 and the standard deviation is 2. His class has 10. So I'm going to just draw a number line real quick to kind of explain where this answer is coming from. So I have 6. That's where my mean is. And I know standard deviation is 2. So how many 2s does it take to get to 10? There's 8. There's 10. So it took me 2 2s, because it's 4 away, and they were to the right. So the answer is A, 2 standard deviations to the right. And that's how you do these problems where they're written out with how many standard deviations away. You just start in the middle with the mean, and then you count how far, or how many, you count by whatever standard deviation is. So in this case, I counted by 2s, and I'll do this again on problem 5. So we'll count by a different number on 5. So it took me 2 2s to get to 10, and that was to the right because it was bigger. All right, here we have a branch or a bank, and it has different branches and different wait times. Which of the branches has the most inconsistent wait time? So I don't need to worry about the mean. It's not part of the problem. What I want to look at is the standard deviation, because standard deviation has to do with consistency. So looking at these numbers, this one is the most inconsistent. You know, as I said this one instead of trying to pronounce that word. Most inconsistent, and the reason it is the highest standard deviation. The bigger the number, I'm trying to sit back in my chair, but I keep going out of the screen. The bigger the standard deviation, the more it deviates. The more inconsistent. That's what I meant to say. It was true what I said the first time, but I meant to say more inconsistent. Okay, last one. We have some jewelry, and it says the mean. I'll use X bar this time. It doesn't matter if we're not actually calculating it. We're just talking about it. The mean is 75. The standard deviation is 20. And the jewelry is 15. So I'm going to draw another number line like I did before. Where am I going to draw it? Right here. And the middle is 75. And how many 20s does it take to get to 15? So the mean is always in the middle, and the standard deviation is what we're jumping by. So if I go by 1, I'm at 55, because I said, when I go that way, when I go to the left, I subtract 20, or when I go to the left, I subtract, and I'm subtracting 20. And then there's another one, which would be 35. And the last one gets us to 15. So I went 3 spaces, 3 standard deviations, and I went to the left because the price was smaller than the mean. The mean is in the middle, and the standard deviation is the size of the jump. And the left or right depends on, is your number bigger or smaller than the mean? This one, the number was smaller than the mean, so it's to the left. The top one, number 3, the class with the blue eyes, that number was bigger than the mean, so it's to the right. All right, if you have any other homework questions, just shoot me an email and I'll be happy to help. All right, see you in the next video.